Hey, welcome back to Hail Design Tech. My name is Jeremiah, and today on this video I'm going to build this torch height controller completely from scratch and for about 50 bucks. So this is the Hail Design Tech torch height controller, completely open source. Here's the design in a Fusion 360. I'll be able to post these files and feel free to edit them to your liking. The main concept is it's three built-in boards, so there's no electronics trying to figure out what resistors you need and capacitance and all that stuff. None of that. Just three main boards, off-the-shelf components. So a TFT display, the Next-Gen TFT35, a TMC 2160 motor driver, and an Arduino Uno. Each one of these components are under 30 bucks each. So 20, 30, and I think like 10 to 15 for the driver board. Got a couple extra fans and some I/O input-output. Everything kind of gets wired to the Arduino, and it does all the torch height control calculations. And that's it. So it's completely open source. Feel free to add and modify this to fit your needs. All right, here's the Arduino sketch, and here's the Arduino IDE version 1.8.13. That's what I used to build it, and it's well commented. It's got a good description. Posts its affiliated software. I use 3 extra libraries that are not my code, but are open source and that allow me to use them. Then the Arduino sketch handles all inputs from your plasma cutter, and step and direction pins come out. Then a bunch of different variables for calculating the position of the torch head, and does a lot of setup, enables your motor driver, and then runs through this main loop, which talks to the user display, and if the user display is good, then proceed to receive some input from your plasma cutter. If the input is over a certain threshold, which you can set, then hop into torch height control mode. And once I'm in torch height control mode, I stay in torch height control until I'm done with the cut, or till the input drops off to below the threshold voltage. Pretty straightforward. What I'm just going to do is use PID control, and that stands for proportional integral derivative control. Allows you to so how fast is it going to move the torch to get to where it's supposed to go? And so you tune these values, and you can tune these in the user settings to match your actuator that you're going to be running this off of. And then it sends step and direction signals, and then recalculates for a new voltage. And so what it's trying to do here is target a certain plasma voltage coming off your plasma cutter. Few good settings here. Everything's going to be documented on my Open Builds build, as well as up on GitHub. You'll be able to find all this info on this sketch. So the rest of the sketch is all user interface stuff, handling events from the Next-Gen screen. All right, and so download this piece from my GitHub and load it onto your Arduino via USB cable. And you'll need to do that before you start putting together the, well, actually no, you can do that after, but the next part you'll need to do before you put the torch height controller together. So let's hop over to the next bit, which is the Next-Gen Screen software. And at the top here, I list the software version that is compatible with. So I'll release Next-Gen Screen versions as well. So the version of this software at this moment is version 1, and the version of the Next-Gen Screen that it's compatible with is also version 1, and those are up on my GitHub. This is the Next-Gen Display Editor released by Next-Gen, and you can get it at nextgen.tech.com. My version I'm using is 1.16.2, and you can load the torch height control graphical user interface .hmi file found on my GitHub, along with the extra media attached, where there's a couple images. So you load those. I'll load mine. It opens like this. So here's the project, and this is what the user will see when you first power on the torch height controller. And this stays active for 2 seconds, and then goes to page 1. And so you can set these different codes to do whatever you want. So page 1 is this one, steel. And if I'm cutting mild steel, I can pull the set point from the Arduino and then start reading plasma voltage. And then this slider goes back and forth to set the set point. And once the voltage is over a certain level, the Arduino will catch the and start trying to meet this set point, and start moving your current position up and down to do that. Then there's 6 different types of material that be cut and 6 different savable set points: steel, brass, copper, and a custom one, so if you're cutting something weird. Then there's a bunch of settings pages. So it'll grab and store settings in the Arduino's EEPROM, and you'll be able to adjust them here on the fly. And then if you're finding your plasma voltage is too high or too low for whatever reason, you can manually set an offset, which will basically just add or subtract from your plasma voltage up to 50 volts, I believe, with the slider here. And if you messed with it, you can always hit reset. But that's the user interface. And we'll load this onto the Next-Gen screen before we assemble everything and put it together, because you need to load this onto an SD card by going to, then using TFT file output. And that will create, I don't know, you can't see this window, weird. And that will create a file that you load onto an SD card, micro SD card, and then you load that onto the Next-Gen display and power it up. It'll read it, and then the next time you power it up, it will display your project. Pretty simple, easy to do. There's plenty of tutorials out there for Next-Gen, so I'm not going to cover that too much in this project. But feel free to modify this file as much as you want. And you might have to redo these pictures because this editor is not as smart when it comes to trying to reproduce the project file. So you may have to do some of this project stuff yourself if you want to mess around with this. Or you can take the preloaded TFT file and use that on your Next-Gen display. But that only works on a TFT 035 Next-Gen display. There's tons of different displays out there, but it only works with this model down here exactly. So the NX4832 T035-11. That's what this was designed for, and you can't use my precompiled file on any other display. All right, let's get to assembly. So I fabricated all the parts for this guy, and these were earlier iterations of my design. And then those are 3D printed parts. And then this is the final design of it. These guys just came off the printer. This took 9 hours, 4 hours, and like 3-ish. And then my little label here took like 30 minutes. These are the 3D printed parts for it. Then we'll need an Arduino Uno and an MKS TMC Trinamic 2160 OC overcurrent, I think, version 1 board. Picked these up pretty cheap. That's why I'm using it. And then we'll need some connectors to kind of route everything into these connector out ports. Everything will come in these in and out ports here and here on the side. So the last piece of the puzzle is this Nexion screen. And I got myself a 48 by 32, a T035 model, which is they offer a few different levels. This is kind of like the lowest end one. And this is all our touch interface. We'll talk to the Arduino. The Arduino will send signals to this guy, which will drive the board. Then we got a few fans to kind of keep everything cool. This guy puts out a bit of heat. And last but not least is a signal smoothing. Well, that's 3.3. Where's my... Oh, yeah, I remember. I fried my other one. Hold on. I've got more. It helps to have little packs of these. Around. Yeah, I fried my 1 microfarad capacitor. That's kind of what I found works the best, at least with my plasma cutter. And we'll hook this between input signal and output of the signal coming in from the plasma cutter to kind of reduce the noise on that line. Not technically needed, but it's definitely helpful. So that's the last piece of the puzzle. So to assemble this bad boy, we can put the Arduino onto its baseboard, the driver board onto the backboard, and then the Nexion goes onto the front interface with the fans. So let's get at it. So the first consideration here is wiring. This will come out to the out port of the motor out. So that's already wired up for me. I run it to Cat5. And then this will need anywhere between 6 to 36 volts to drive my motor. And the Arduino itself will need somewhere between 6 to 12 volts to drive it. So I found a happy medium between the two. This probably shouldn't be run so low, but it works. So I'm gonna run them both on 10 volts. And to do that, this guy is gonna take power directly from the Arduino. It's too much current just to steal it directly from one of these out pins. So I'm gonna solder directly to the barrel connector at the bottom here. And that will give me my good current connection. So actually, let's do that first. So we'll strip the wires down and solder them up to the bottom of the Arduino board. Okay, took a quick look at my plans. Yep, so negative, positive. Could pull off these two. And we'll go ahead and solder that up right now. All right, burnt a little bit of those wires. Was not the best connection in the world, but it should work. Now it needs the wire itself needs to run directly underneath the Arduino or over the top. So I think it's best just to run it right over the top. I got plenty of room to do that, so that's the way it's gonna work. And that way I'm not pinching the cable against the base plate. So let's get it installed. M3, anywhere between an 8 to a 10 millimeter M3. That works out, or whatever fastener floats your boat. Because I'll make the design files available and you can play around with the sizes. Okay. All right, that's your Arduino board. Solder or fastened to this bottom plate. And we got the motor power running off it already. So let's mount that next. This will mount to the back board here. This is the back of the unit. And this is intentionally, even though it has 4 holes, this one is completely filled in because, again, I don't think it's easy enough to put a screw down into there, and I don't want to risk puncturing that capacitor there. So we'll just use 3 screws on the back. Okay, and uno más. Okay, that looks beautiful. So we got our board mounted in here. This will drive our motor. This feeds a output jack, which can go on the top or the bottom here. Arbitrarily, I'm just going to use the top one for my motor out. This will just snap in, no bolts or nuts and stuff required. I realized I wasn't recording for some of that. Whoops. All right, so I think I left off with, so we got the next-gen screen attached here with the nuts and little 3 millimeter screws. Should fit nice and easy in there. Don't over tighten these. There's no real reason to, and you could flex and break the next-gen screen if you over tighten it. And at this point, we're done with the solder. There's no other things you need to solder. So to hook up the Arduino so it can talk to the next-gen screen, we just need to do a simple 2-wire serial connection. One for information going in, one for information going out. So R is receive, T is transmit or out. So we just need to plug these into the Arduino. So in this case, yellow is receive and blue is transmit. When we need to plug those into the opposite on your Arduino board. So to receive signals, you need to transmit them from your Arduino and vice versa to receive them from the next-gen screen. So yellow goes into transmit and blue goes into receive on the Arduino side. And then now the Arduino can talk directly via serial to the next-gen screen and do all the updates it needs to do. Then for power, we just need a 5-volt steady signal, and the Arduino can provide that on the 5-volt out and ground. So there's these 2 pins right here. Okay. And what I'm using for connectors here are just wires that are soldered onto input pins that fit directly into the Arduino. Just solder them directly on. You can do, in lieu of doing that, you can just use a set like this that have these wires that are designed specifically to go into breadboards and which will also work into the Arduino connection boards. The downside for these is they tend to break. So that's why I opted for those kind of connections. Next, beef jerky time. Oh, you heard beef jerky? You want some? I'll pull it back into here. You know. Alright, rest of mine. Beef jerky break, check. Next, let's hook up the driver board to the Arduino. Orange and red, where orange is my step, red is my direction, and those come out as 3 and 4. Where 3 is step, 4 is direction. Then yellow is enable and orange is ground. Goes into pin 13 and ground. This little guy, like I alluded to before, we'll use this 1 microfarad capacitor will be used to clean up the signal. The longer pin is positive, the shorter one is negative. So the positive would go into the analog read side, and the other one would go into ground. So that's the first thing you do, is excuse me, next screen, you're in the way. So for analog in here, no, it's kind of small. We'll just literally just plug this capacitor in here without solder. No need. It'll be held in with the connecting wires. So just put it in here like that. Negative goes to ground, positive goes to the analog read, A1 on the Arduino. Then yellow here for me is my ground signal coming off my plasma cutter. That goes in the ground into the same pin that your capacitor is in there. On. Takes a little bit of finessing because it's a tight fit with the two wires in there, but it works. And this seems to be worked the best way for me. If you got a better idea, go for it. This is not set in stone or anything. And so what that does is it locks the capacitor into place, push it down and out of the way, and then we've got our input signal here, which will go into our back plate. Okay, as far as the build goes, we're about 90% done. All we need to do is kind of put stuff together and wire up our exhaust and intake fans. So we'll need 8 M3 by 20 millimeters, and then 8 fasteners to get these fans mounted correctly. And then we want to mount this being the intake, this is the exhaust. So we want to intake air in the front here, exhaust it across our heat radiator there. So the fans need to be mounted like this, in this orientation, on the front here. Okay, looks like my fans are attached there. And you can kind of put these in any orientation that you want, as long as they're facing the right way. Then we will power them with the connecting style of your choice. Cut these and find a way to power them off of the Arduino or a relay board if you want to get that crazy. But I'm just going to solder these directly, not solder, but attach them directly here to these input pins for the main power of the driver board. So my fans will be powered off right here. And we'll just need a little regular screwdriver to tighten the fasteners. So in this case, red is positive, which is nice. So connect our positives together. Just do a little twist connection. And then we'll do the same for the negatives. To make a safer connection, we could put these in ferrules. And what a ferrule is it's just an extra piece of wire or pipe, small tiny pipe that fits over the top of these and does the crush connection. Often these are filled with some sort of a rust inhibitor or acid buildup inhibitor. But all we'll need to do is put these in their respective little guys. What? This one's already been used. Lame. Who uses a ferrule and puts it back in its double tightening? Okay, those look like they're on there. And so those just tidy up the end connectors without having to solder anything extra. All right. And then my dumb butt just put it in backwards. Ah. Yeah, don't hook these up backwards because they won't work. I don't think it'll fry anything, but it just won't work. Don't do it like I do it. You know, probably you should find a better way to do this connection. But in a pinch, it'll work. I don't know why I'm pinching things. Okay, so let's put it all together. Tuck my wires in place. put my top down. Then the back goes on, like so. So make sure these wires aren't rubbing on the motor connectors or fan blades. Connection, your wires are really in my way. Thank you. This fits onto the back like so. Then all of our components items are now fit together with a ton of M3 screws. M3 12 millimeters, that's what I meant. If they're too long, they'll bust the plastic. Voila. He's so pretty. Yeah, do something about those fan alignments, but other than that, she's golden. So, that automatically goes to processes. What are you cutting? Mild steel, next stainless, next aluminum, and then your oddballs, copper, brass, and custom. If you want to know more about the Auto Crafter, I got some videos popping up on the screen here and over here somewhere. Go ahead and check those out, and see you later. Peace.